The ocean looks empty from above. Just water, wind, waves moving endlessly toward distant coastlines. But hidden beneath the surface, entire industrial worlds are already operating in silence. Far from cities and highways, floating cages the size of football fields drift in cold coastal waters. Inside them, millions of living creatures move in synchronized circles beneath steel walkways and automated feeding systems. This is no longer traditional fishing. It is ocean farming on an industrial scale. And every day, these floating systems help feed a planet that consumes more seafood than at any other point in human history. What once depended entirely on wild oceans is now increasingly controlled by machines, sensors, underwater infrastructure, and biological engineering, because modern seafood demand has become too large, and the natural ocean can no longer keep up alone. The transformation begins with salmon. In some farms, salmon are raised in waters more than 25 meters deep, where temperatures must remain within a narrow survival range. To warm and disease spreads faster. To cold and growth slows dramatically. Everything depends on balance. Water temperature, oxygen concentration, salinity, current speed, fish density. Millions of dollars can be lost if even one part of the system fails. From above, salmon cages appear calm. Below the surface, they behave more like living factories. Thousands of fish move continuously through circular currents created by the structure itself. Their movement distributes oxygen evenly through the cage, while reducing stress inside the population because stress changes everything. Stressed salmon grow slower, consume more energy, develop disease faster, and produce lower quality meat. So the farms are designed to control not only the fish, but the environment surrounding them. Long before the salmon ever reach the ocean cages, the process already begins inside highly controlled hatcheries. This is where millions of fertilized eggs are carefully incubated under constant supervision. Rows of trays stretch across temperature-controlled rooms, while technicians monitor oxygen levels and water conditions around the clock. At this stage, salmon are extremely fragile. Even small fluctuations in water quality can destroy entire batches before they hatch. For weeks, the eggs remain inside artificial systems designed to imitate the natural rivers where salmon once began their lives. Only now, nature is being recreated through engineering. The goal is efficiency, predictability, survival. As the juvenile salmon continue growing, another transformation begins. Their bodies slowly adapt from freshwater life towards saltwater survival in a biological transition known as smoltification in the wild. This process would happen during long migrations downstream toward the sea. Inside industrial aquaculture, the transition is carefully managed and accelerated under human supervision. Once ready, the young salmon are transferred into open water cages along the coastline. And this is where the scale of the industry truly becomes visible. Beneath each floating structure, massive containment nets descend deep into the ocean while automated systems continuously circulate water through the cages. Sensors monitor oxygen concentration every hour. Feeding systems distribute specialized diets with mechanical precision. Workers inspect fish behavior daily, searching for early signs of stress or disease, because inside these cages, biology and economics are now inseparable. Every salmon represents time, feed, fuel, infrastructure, labor, and above all, survival rates. A healthy salmon may take nearly 20 months to grow from a juvenile weighing only a few hundred grams into a full commercial fish weighing over 5 kilograms. That means the system must remain stable for almost 2 full years. Storms cannot destroy the cages. Disease cannot spread through the population. Water quality cannot collapse. The fish are no longer simply being raised. They are being maintained inside an artificial biological environment that must operate continuously without interruption. And the larger the farms become, the more fragile that balance starts to feel. Modern salmon farming depends on constant observation. Workers monitor feeding patterns to detect subtle behavioral changes. Current speeds are adjusted to reduce stress. Stocking density is carefully managed to prevent overcrowding. Even the placement of the cages matters. Too close to shore, and water circulation weakens. Too exposed, and storms can damage infrastructure. The ocean itself has become part of the machinery. But, despite all the technology, the farms remain vulnerable to the same force. Humanity has struggled against for centuries. Nature. A sudden algae bloom can reduce oxygen levels across entire regions. Water temperatures can shift unexpectedly. Parasites and disease can spread through densely populated cages faster than workers can contain them. And when millions of living animals depend on one interconnected system, small problems become industrial disasters. Yet the demand for seafood continues rising every year, so the cages continue growing larger. The systems become more advanced, and humans push further into the ocean searching for greater control. But salmon are only the beginning. because some species refuse to adapt so easily to industrial life. And the deeper the industry moves into the ocean, the harder nature becomes to control.
For a moment, it seemed like humanity had solved the ocean. The floating salmon farms worked. The hatcheries worked. The feeding systems worked. Machines could now regulate temperature, oxygen, water flow, and disease with extraordinary precision. An entire living species had been pulled into a controlled industrial system. But then the industry attempted something far more ambitious. It tried to industrialize wild predators. And suddenly the illusion of control began to crack. Because salmon were only partially wild to begin with, tuna were different. Lobsters were different. These animals had evolved for open oceans, deep currents, migration, aggression, and constant survival pressure over millions of years. And no amount of steel infrastructure could completely erase that. The first warning signs appeared inside lobster farms. At first glance, the systems looked efficient. Underwater cages protected the lobsters from storms and predators, while allowing fishermen to raise them in dense commercial quantities. But beneath the surface, the farms behaved less like stable ecosystems, and more like biological containment zones. Like salmon, lobsters do not naturally tolerate crowded industrial environments. They are territorial, sensitive to stress, highly dependent on water quality, which means the cages must constantly fight against the lobster's own natural behavior. Workers monitor stocking density carefully because even small increases in population pressure can trigger aggression and mortality. Every enclosure becomes a balancing act between biology and economics. More lobsters mean higher profits, but also higher instability. Slowly, another problem begins accumulating beneath the cages: waste. Large amounts of bait fish are fed into the systems daily to sustain commercial growth. But the ocean does not remove waste instantly. Fine mesh nets trap uneaten food, biological debris, and sediment inside the enclosure while organic buildup spreads beneath the structures. So the farms require constant human intervention just to remain functional. Workers inspect cages daily. Waste must be cleaned manually. Water conditions must be monitored continuously. Because if circulation weakens for too long, the system begins collapsing from inside itself. This was the contradiction industrial aquaculture had started to discover. The more humans concentrated ocean life into controlled systems, the more unstable those systems became. But lobster farming was still manageable compared to what came next. Tuna, bluefin tuna, are among the most valuable seafood species in the world. In over decades of industrial fishing, wild populations were pushed toward collapse in some regions of the Atlantic. So, aquaculture attempted to do what modern industries always attempt when natural supply begins disappearing: scale production artificially. But tuna exposed a dangerous reality. Some ocean creatures were never designed to live inside human systems, because tuna are built for motion. Their bodies consume extraordinary amounts of oxygen while generating constant forward movement through open water. They do not drift calmly through cages like domesticated animals. They move continuously, endlessly, if movement slows. Oxygen exchange weakens, stress rises, survival drops. So the cages cannot simply contain the fish. It must recreate enough of the open ocean to keep the predators alive. And suddenly, the industry faced a terrifying engineering problem. The ocean was not becoming part of the machine. The machine was struggling to survive inside the ocean. Massive offshore cages were placed in deep, nutrient-rich waters where strong currents could maintain oxygen flow through the system. The structures had to survive: storms, salt, corrosion, pressure from ocean currents, and the immense physical force generated by giant tuna circling endlessly below. Every part of the infrastructure depended on uninterrupted environmental stability. Because tuna farming does not control nature, it negotiates with it. And the economics behind the system only intensified the pressure further. To produce a single kilogram of tuna, farms may require 15 to 20 kilograms of feed fish. Entire schools of smaller fish are harvested simply to sustain one premium predator species, which creates another contradiction. Industrial tuna farming was supposed to reduce pressure on wild oceans. Instead, it still depended heavily on extracting life from the sea itself. Workers feed the tuna constantly using sardines, anchovies, and fresh bait fish selected to match the instincts of wild tuna populations. And during feeding operations, the illusion of domestication disappears instantly. The surface explodes into violent turbulence. Hundreds of massive predators surge upward through the water at full speed, while workers scatter tons of bait into the cages. For a few seconds, the industrial systems reveal what they truly are, not farms, containment structures. Because despite years of engineering, automation, and monitoring, these animals are still fundamentally wild, and the larger the industry grows, the harder that reality becomes to hide. Storms continue damaging infrastructure. Waste continues accumulating beneath cages. Feed costs continue rising. Disease risks remain constant. So the systems become larger, more mechanized, more dependent on surveillance and intervention. But with every expansion, another uncomfortable truth emerges. Humanity has not fully industrialized the ocean. It has only learned how fragile its control really is. And beyond the cages, the ocean itself is beginning to respond.
For decades, the seafood industry believed technology could solve the ocean if fish populations declined. Build larger farms if natural harvests became unstable. Increase production systems if the sea became unpredictable. Monitor it more closely. And for a while, that logic appeared to work. The cages expanded, the harvests increased. The global seafood trade continued growing. But slowly, another reality began emerging beneath the surface. The ocean was not simply supporting these systems, it was absorbing them. And every industrial farm, no matter how advanced, remained completely dependent on an ecosystem no machine could fully control. Nowhere is that contradiction more visible than in oyster farming. Unlike tuna or salmon, oysters do not hunt. They do not require massive feeding operations. They survive by filtering the ocean itself, quietly, continuously. In many coastal regions, oyster farms stretch across shallow waters in long floating rows, exposed to tides, sunlight, storms, and seasonal temperature changes. At first glance, these systems appear almost peaceful compared to the violent industrial scale of offshore fish farming. No giant predators, no feeding frenzies, no automated bait systems, just cages floating silently with the movement of the tide. But the calm surface hides another kind of fragility, because oyster farming depends on something modern industries often struggle to preserve: environmental balance. Young oysters are initially protected inside floating cages, where water, circulation, and positioning become critical to survival. If cages sink too deeply into soft seabeds, the oysters can suffocate in mud. If winter temperatures become too severe, entire populations may freeze. Even biological growth on the cages themselves becomes a constant battle. Barnacles, algae, marine organisms. Over time, the ocean slowly attempts to reclaim every artificial structure placed inside it. So workers constantly rotate cages into sunlight to dry out biological buildup and reduce fouling across the system. The farms survive through maintenance, not control. And unlike industrial tuna operations, oyster farming reveals something unexpected. Sometimes producing less creates healthier systems. In some regions, farmers deliberately reduced the number of cages in the water after realizing overcrowded farms were placing too much stress on the surrounding ecosystem. The results surprised them. With fewer cages competing for nutrients, individual oysters grew faster, healthier, and more consistently. For a moment, the industry encountered a rare contradiction inside modern industrial food production. Bigger was not always better, because the ocean still operated according to biological limits no algorithm could rewrite. And oysters themselves exposed another uncomfortable truth about the relationship between humanity and the sea. The farms needed healthy oceans, because the oysters were filtering the water those systems depended on. Every oyster continuously processes surrounding seawater, removing particles and organic material as it feeds. The industry was no longer simply harvesting nature. It had become dependent on nature functioning properly in return. That dependence changes everything. A disease outbreak in one region can spread rapidly through connected marine environments. Rising ocean temperatures alter oxygen conditions. Pollution from coastal development weakens water quality before it ever reaches the farms. And unlike machinery failures, these problems cannot simply be repaired with replacement parts. Because ecosystems do not follow industrial schedules, they change slowly. Then, suddenly, the seafood industry had spent years attempting to stabilize production through engineering, but the ocean remained unstable by nature. Storms shift currents, temperatures fluctuate unexpectedly. Algae blooms can spread across entire coastlines, and every seafood system floating offshore remains vulnerable to forces operating far beyond human infrastructure. The contradiction was becoming impossible to ignore. Modern aquaculture depended entirely on the health of environments industrial civilization was already placing under pressure. The farms were not separate from the ecosystem, they were trapped inside it. And the deeper humanity pushed into industrial ocean farming, the more obvious that dependence became. Yet while coastal farms struggled to maintain ecological balance near shore, another part of the seafood industry still operated much farther from safety. Far beyond protected bays and floating oyster cages, fishermen continued entering some of the most dangerous waters on Earth. Because despite all the cages, sensors, and industrial systems, a large part of the modern seafood economy still depends on men willing to gamble their lives against the open sea.
For years, the seafood industry tried to reduce uncertainty, build stronger cages, monitor oxygen levels, stabilize production, predict biological behavior. Near the coast, technology had begun transforming parts of the ocean into controlled industrial systems. But farther north, the illusion of stability disappears completely, because there are still places where seafood can only be harvested the old way, by entering the open sea directly. And in the freezing waters of the Arctic and North Atlantic, modern fishing remains one of the most dangerous industries on Earth. Long before sunrise, vessels push through dark water beneath freezing winds, while crews prepare equipment on decks already covered in ice. Out here, nature is not something being controlled. It is something being survived. Cod fishing has existed for centuries in northern waters, feeding coastal economies long before modern aquaculture systems ever appeared. But industrial fishing in icy seas demands a level of endurance most people never see. In winter conditions, seawater freezes instantly against steel surfaces as waves crash across the deck. Hour after hour, ice accumulates on railings, machinery, cables, and equipment. And slowly, the vessel itself begins growing heavier. Too much ice buildup can destabilize entire ships. So crews work continuously in freezing darkness, breaking and removing ice while the vessel is still moving through rough water, not because it improves efficiency, it's because it prevents sinking. This is the reality modern seafood systems still depend on, not just machinery, human endurance. Once the cod are brought aboard, the work accelerates immediately. Fish are processed as quickly as possible in brutal weather conditions while crews cut heads, remove organs, and prepare the catch before spoilage can begin. In warmer oceans, delays can destroy meat quality rapidly. But here, the cold itself becomes part of the preservation system. The environment threatening the fishermen is also protecting the harvest. Again, the ocean operates according to its own logic, not industrial logic. Workers move carefully across frozen decks, while steel equipment swings violently beside them. Everything is wet, heavy, slippery, cold enough to numb exposed skin within minutes. And yet the vessels continue operating for weeks at sea before returning to shore. Because the economics of industrial fishing demand scale, fuel costs are enormous. Whether windows are limited, profits depend on maximizing time inside productive fishing grounds, so the crews stay longer, push farther, work harder, even as conditions become increasingly dangerous. But some fishermen move even deeper into frozen environments. Onto the ice itself. For generations, ice fishing depended mostly on instinct, local knowledge, and patience. A fisherman drilled through frozen lakes, dropped bait into darkness, and waited.
Ow.
Now, even these ancient traditions are slowly being absorbed into modern technological systems. Electronic sonar systems scan beneath thick ice layers in real time, allowing fishermen to track fish movement below the surface with astonishing precision. The contrast is striking. One of humanity's oldest survival activities now depends on digital imaging. Live scanning systems and portable electronics operating in sub-zero environments. Still, the ice remains dangerous no matter how advanced the technology becomes. Fishermen constantly monitor ice thickness before moving farther from shore. Snowmobiles transport equipment across frozen surfaces that can crack without warning. And nobody ventures onto the ice alone, because here, mistakes are rarely survivable. Yet even these frozen lakes are calmer than the open waters hunted by king crab vessels. Far north, near the edges of Arctic ice, massive fishing ships operate in some of the harshest commercial environments on the planet. These crews actively search for freezing water because that is where king crabs thrive. The deeper the cold, the closer the fishermen move toward it. Huge steel traps weighing hundreds of pounds are lowered into dark ocean depths through hydraulic systems powerful enough to withstand constant stress from waves, ice, and extreme weather. Everything about the operation feels heavy. Heavy machinery, heavy seas, heavy exhaustion. Workers pull lines with frozen gloves while hydraulic cranes swing massive traps across unstable decks coated in ice. The labor becomes repetitive, relentless, mechanical, and after enough days at sea, the boundaries between men and machinery begin blurring together. Sleep disappears into rotating shifts. Weather forecasts become survival calculations. Every movement across the vessel carries risk. Out here, seafood is no longer connected to restaurants or luxury markets. It becomes something far more primitive. Extraction. Human beings entering hostile environments to remove food from systems stronger than themselves. And despite all the technological progress of modern aquaculture, the seafood industry still depends on people willing to stand on frozen decks in the middle of violent oceans. That reality changes the way the entire system looks, because behind every cage near shore, every premium tuna auction, every oyster bed, every seafood market in the world, there are still workers battling conditions no machine has fully conquered. For all humanity's attempts to industrialize the ocean remains more powerful than the systems built inside it. And as global demand for seafood continues rising, another question begins emerging beyond the storms and machinery. How long can these fragile systems continue feeding the modern world? For thousands of years, the ocean felt infinite. Storms came and went. Fish populations shifted with the seasons. Coastal communities harvested what they needed from waters that seemed impossibly vast. And for generations, humanity believed the sea could absorb almost anything. More ships, more nets, more demand. But modern civilization changed the scale completely. Today, seafood is no longer a regional food source tied only to coastal villages and fishing towns. It is a global industrial system feeding billions of people across interconnected economies, stretching from Arctic ports to massive urban supermarkets thousands of miles inland. And somewhere inside that transformation, the relationship between humanity and the ocean fundamentally changed, because the seafood industry no longer simply harvests nature. It now attempts to manage it. Across coastlines around the world, floating cages hold millions of farmed fish inside engineered environments. Sensors monitor oxygen levels continuously. Workers regulate feeding systems with industrial precision. Entire hatcheries exist to control the earliest stages of aquatic life. Humanity has spent decades trying to stabilize something the ocean never evolved to keep stable, and in many ways, it succeeded. The industry can now produce enormous amounts of seafood at scales impossible only a generation ago. But every system revealed another dependency. Salmon farms depend on tightly balanced biological conditions. Lobster cages require constant maintenance to prevent collapse. Tuna farms consume staggering amounts of ocean resources simply to sustain a single predator species. Oyster farms survive only if surrounding ecosystems remain healthy. And beyond the farms themselves, wild fishing fleets still battle ice, storms, exhaustion, and physical danger to keep seafood flowing into global markets. Every solution created another layer of fragility. The deeper humanity pushed into industrial ocean production, the more interconnected everything became. A temperature shift in one region now affects harvests thousands of miles away. Disease outbreaks spread rapidly through dense aquaculture systems. Fuel prices alter fishing economics across entire industries. Ocean warming changes migration patterns that commercial fleets have depended on for decades. Nothing operates independently anymore. Not the farms, not the fishermen, not the ecosystems, and certainly not the consumers, because most people never see the true scale of the system feeding them. They see seafood carefully arranged on ice inside supermarkets, perfect salmon fillets inside restaurants. Luxury tuna served across polished counters beneath soft lighting. What remains invisible is the machinery underneath. The hatcheries, the underwater cages, the feed ships, hydraulic crab systems, the frozen decks covered in ice, the workers standing in darkness before sunrise, the endless maintenance required simply to keep the system functioning one more day. Modern seafood no longer comes directly from nature. It comes from an enormous industrial negotiation between humanity and a living planet. And that negotiation grows more unstable every year. The contradiction sits at the center of the entire industry. Human civilization depends increasingly on seafood as populations continue growing. Yet the ocean systems supporting that demand remain biologically fragile, environmentally sensitive, and impossible to fully control. Technology can monitor the water, but it cannot stop storms. It can automate feeding, but it cannot eliminate ecological limits. It can expand production, but it cannot remove humanity's dependence on stable oceans. And perhaps that is the realization modern industrial society struggles with most. For all our engineering, all our machinery, all our global supply chains, human survival still depends on systems we did not create. The ocean does not operate according to economic forecasts or industrial schedules. It follows pressure, temperature, currents, biology, time, and every floating cage, fishing vessel, sonar system, and offshore platform exists entirely within those forces, not above them. The seafood industry once believed it was industrializing the ocean. But after decades of expansion, another truth has become impossible to ignore. Humanity is not mastering the sea. It is learning how difficult survival becomes when an entire civilization depends on keeping a living ocean alive. And far beyond the ports, the factories, and the markets, the water keeps moving exactly as it always has. Cold, dark, unpredictable. A force large enough to feed the modern world, powerful enough to remind humanity that it never truly controlled it at all.